In a world surrounded by space. Space of mystery. Space for exploration. Space for CubeSats. Space for DVDT.
CubeSats are low-cost, miniaturized satellites made for research purposes. These CubeSats orbit the Earth, collect data, and then fall and burn into the Earth's atmosphere. All data is lost. This is where DVDT comes in. DVDT is a team of engineers designing a communication board for CubeSats to talk with Earth while in orbit.
Our board will be integrated into an existing system called the Modular Integrated Stackable Layer, or missile stack, into an existing CubeSat called the TSAT for our client, T-Star. My name is Trent Tate and I'm the project manager of DVDT. Now it's time to meet the rest of the team.
Howdy, my name is Dakotah and I'm the hardware engineer. My job is to design the communications layer, which will integrate fully and comply with all specifications of the missile stack architecture. This includes both the full schematic capture and board layout. Along with designing the communications layer, I'll be in charge of the base station mockup, which will be used for all functionality testing.
Howdy, my name is Vince Rodriguez and I'm the software engineer. My main role is to create embedded software that allow us to communicate between the intelligence layer and our newly created communications board. I'll be doing this with an all-new RTOS architecture that allows us to not only use our board, but also add scalability for use of future projects.
Howdy, my name is David Smith and I am the Systems Integration Engineer. My duty is to integrate our communications layer with the RTOS software that we develop. Additionally, I'll be creating a test plan that ensures line-of-sight communications between our board and an Earth base station. I'll be working closely with the hardware and software engineers to ensure project success.
Here's our conceptual block diagram, which illustrates our project of communicating from a TSAT down to a base station on Earth. This base station mock-up is used for line-of-sight testing to our communications layer. This system is purely for verification purposes, and a complete design is not within the scope of our project. As mentioned earlier, our layer will be integrated into the missile stack architecture. This includes conforming to all specifications of the defined missile stack power and data bus connectors. A new power connector will also be added to our board to allow for larger power consumption. The intelligence aspect of our system will be an MSP430, which has already been designed on a different layer. Here's where our real-time operating system and embedded firmware will be located. Our system intelligence will communicate with our LoRa chipset over the missile data bus using SPI as the protocol. From there, our LoRa chipset will modulate our information and will be sent out through an antenna on the exterior of the TSAT. Also on our communications layer will be additional memory, which will communicate over I2C and be used for storage of data when our device is waiting to transmit or receive. Lastly, our board will have an expansion port which allows for further protocols such as digital, analog, or serial communications to be added for integration of sensors and customization of projects for our customer.
We are very excited to be serving our client, T-Star, and would like to say a special thank you to our senior advisor, Mike Willey. For any additional questions, please contact us at dvdt.capstone@gmail.com.